Okay, let's briefly talk about the transport we're going to be using to get our messages published and consumed by our different services. And what is RabbitMQ? Well, effectively, it's a message broker. It accepts and forwards messages. So it accepts, in the case of RabbitMQ, it accepts a message into an exchange, and we'll talk about exchanges soon, and it forwards the messages to a queue that services can subscribe to. And it uses the producer and consumer model, or publish-subscribe model. Both of those terms are kind of used for this, but the term I'll try and use most is the producer and consumer, because the thing that we're going to use to make our connection to Rabbit's MQ, which is called mass transit, which we'll talk about briefly in this lesson, that's the terminology that uses, producers and consumers. But effectively, it's a publish-subscribe model. So messages are stored on queues, and it uses a message buffer, and RabbitMQ can have persistence associated with it too, so that if the RabbitMQ service fails, and we need to create a new one in its place, then it can receive the messages that are stored inside the message buffer, which will be persistent on storage, so that we can recover from failure. So it can use persistent storage to store those messages in the event of some kind of failure. Now, RabbitMQ uses exchanges, and there are some differences between the different transports and the terminology that they use, but RabbitMQ, when we publish a message, we send it to an exchange. And exchanges have queues that are bound to it. And we'll talk briefly about exchanges soon, because there's different types of exchanges we can have inside RabbitMQ. And RabbitMQ uses, as do other transports, the Advanced Message Queuing Protocol. And if we briefly talk about the exchanges, there's four that we can have. There's direct, fan out, topic, and header. We're going to focus on the fan out one, but I'll briefly mention what the other ones are for as well. So in the case of a direct exchange, it delivers messages to queues based on a routing key. And the routing key in this small example is bike. So when we publish this message to an exchange, it has a routing key. And then our exchange can route it to a queue based on that routing key, and that can be consumed. And this is kind of like a direct or unicast messaging. It's not the type we're going to use because it can only route to a single queue, and we want something that can be bound to many queues. And the one that we'll mostly be using, in fact will be using, is the fan out type of exchange. So our publisher, and let's say for this example is the auction service, that's going to publish an auction-created event, for example, to an exchange. This exchange has one or more queues bound to that exchange, where it will place the message in a queue that will then wait for a consumer to pick up and consume that message. Now, there can be one queue, there can be two, there can be 1,000. It really doesn't matter. Our publisher of the message certainly doesn't care about that. That's the exchange to then forward that message onto these different queues. And then we can have multiple consumers consuming from the same queue, or multiple queues as well. This is the exchange that we are going to be using for all of our examples coming up. We're actually not going to take a look at any of the other ones at all, because we don't need to for the app that we are building. We can also have a topic type of exchange that does route messages to one or more queues based on its routing key. So similar to the direct exchange, but we can use a routing key and it can go to more than one queue. And a header type of exchange allows us also to specify a header with the message that then our exchange can use to publish it to various multiple queues, one or more queues. But again, this one's a bit obscure and not something that you would typically use, but it is there available for you to use. Our focus is going to be on this fan out exchange, and we're going to get our exchange to publish to one or more queues for each of the messages that we end up publishing. Now, there are options on how we connect to RabbitMQ. We can use the RabbitMQ client itself and use that directly to connect to Rabbit and send our messages. But there is an alternative when we're using .NET, and that alternative is to use mass transit. It provides a consistent abstraction on top of supported message transports, so not just for RabbitMQ. And in a similar way that Entity Framework provides an abstraction from the database technology we're using, mass transit achieves that same goal but it provides an abstraction from the transport so that we can use the same code effectively with some small differences. And if we wanted to use different transports in the future other than RabbitMQ, then by using mass transit, our code changes would be minimal. This does give us some other features that we'll take advantage of, such as message routing, exception handling. It provides a test harness so that when we want to test our code, we can do that in memory, and we don't need an external infrastructure service to provide testing to see if our message functionality is working as we want it to. And we'll also take advantage of dependency injection so that we can easily use the features provided by mass transit to publish and consume messages from our service bus. And we're going to take a look at implementing this next. Okay, it's time to take a look at messaging in our application now. We've got our two services and we want them to be able to talk to each other asynchronously. And in fact, they're not going to be talking to each other, they're going to be talking to the service bus. And what we're going to use for our service bus is RabbitMQ. And we're going to go ahead and add this to our application now. So we'll head over to VS Code, and once again, we're going to use our Docker Compose file to get this service up and running. So below our existing services, below MongoDB, I'm just going to add the RabbitMQ service. I'm going to call the container RabbitMQ, and we're going to use an image. And this image we're going to use actually comes with two things. It comes with the message broker itself, and it also comes with a management utility so that we can see what is going on inside the broker. So we need to use RabbitMQ, followed by a colon, followed by 3-management-alpine. And this will give us the image we need. And we're going to specify the ports, and I'm missing a colon, that's why I'm getting some red squiggles here. And the ports that RabbitMQ runs on by default is going to be 5672, and we'll use that for the external port and the internal port. And we also need to give this an additional port so that we can access the management service, which we can access in a browser for RabbitMQ as well. And that port number needs to be 15672 and 15672. And that's all we need to get RabbitMQ up and running. It does take authentication, but if we don't provide any, then we're going to be able to access it using guest and guest. And let's just start this service and see what happens. So I'm going to go to the third tab inside here, and I'm going to run docker compose up-d, which is going to go ahead and get the RabbitMQ image, and hopefully it will start. And once that's done its thing, then we now have the RabbitMQ service up and running. And if we go take a look at Docker, we can see that we have this up and running, and we can see the logs saying that server startup is complete, which is good. But what we also have inside here is something running on 15672 as well. So what we can do is head over to our browser, and if we go to localhost 15672, then what we should be presented with is the RabbitMQ console. And if we log in using guest and GUEST as the password, guest for both of these fields, then we get to log in and we get to see the RabbitMQ console. So we've got an overview of what's going on. We've got the connections that are currently connected, obviously nothing just now because we've just started it running. We have channels, we have exchanges, which we talked about earlier. This is going to be the window into what we're actually doing with our services. So when we come in here and take a look at the exchanges, this is where our messages are going to be sent to. And from our exchange, then our queues will be populated, and this is where our subscribers or our consumers get those messages from. And then we've got an admin tab as well, which we're not really going to take a look at. But these are the two views that we'll be using consistently to see what's happening with RabbitMQ. As we add additional exchanges, we'll see them in the list and also in the queues as well. But because we're abstracting ourselves away from RabbitMQ by using a package called Mass Transit, then a lot of things are going to happen in RabbitMQ by convention. So when we create a class, and we're going to refer to these classes as contracts, something that two services will both use to send a message and consume a message, then we're going to see those contracts appear as the exchange names inside here. When it comes to creating queues, once again, we're going to see the queues based on how mass transit works conventionally, so that we create queues based on the name of the consumers that we create in the service. Anyway, that will become clearer as we build what we're doing in this particular section. And what we'll take a look at next is actually adding mass transit.